Hello everyone, welcome back to Etu Tutorial, your go-to channel for making data simple and fun. In this video, we're diving into one of the most important parts of SQL, joins. We'll explore how to combine data from multiple tables using inner join, left join, self join, and even full join. Yes, we'll talk about how to simulate that in SQLite too. Whether you are new to joins or just need a refresher, this video will walk you through it, all with clear examples using SQLite on DBeaver. Let's get started and unlock the power of relational data. Joins are used to combine rows from two or more tables based on a related column between them, usually a foreign key in one table that references the primary key in another table. There are different types of joins out there. Some examples include inner join, left join, right join, full join, cross join, and self join. Most SQL dialects like PostgreSQL and MySQL can perform right joins, but SQLite does not. Now we'll look at some of the joins that SQLite can perform. And in this video, we'll focus our attention on these joins. The first is the inner join. It selects records that have matching values in both tables. I see it like an intersection between table A and B, which you can see highlighted by that blue area when the two tables come together or are intersected. The next is the left outer join or the left join. It returns all records from the left table, which is table A, and the matching records from the right table, which is table B. The result is 0 records from the right side if there is no match. The next table we'll look at is the full outer join, or full joins. It returns all records when there is a match in the left table, which is table A, or the right table, which is table B. And the last one we'll look at is the self join. And what this basically means is a regular join, but the table is joined with itself. So you have table A joining back to table A. So for our exercise today, we will need a computer. You would also need the DBeaver software installed. And if you don't have this installed, I have a link in the YouTube description below that would help you install this software. You would also need the Chinook database. I would have a link as well to my GitHub file where you can download this database. And finally, remember to always bring a learning attitude. Now, the questions we'll be looking at for this practice includes the following. Find all tracks, including their album names and the names of the artists who performed them. So this is going to be our first question. And what I've done to all of these questions is to tag them based on the join that we're looking at. So this first question is looking at the inner join. The second question is looking at the left join, which says list all artists and their albums, including artists who have not released any albums. Our third question is on a full join. List all the artist names with their album titles. And then the last question is a self join. Find employees with the same job title. So let's head over to DBeaver and see how we can answer all of these questions. I have these questions already preloaded on my DBeaver to speed up things. So let's start with the very first question, which is an inner join. Find all tracks, including their album names and the names of the artists who performed them. So here we're using an inner join and we're dealing with the track table, which you can see here. We also have to go to the album table and then the artist table. So basically, we're trying to join 3 tables together, right, to give us a result that will answer our question, right? Our inner join, or should I say specifically, our inner joins are going to be based off the albums and the artist, right? But we're going to include all of the results we get from those 2 tables to the track table. So let's see how we can do this. So I have my select statement. So I would use the asterisk first because I want to name the first table, which is tracks. And I'll come back here and edit this. So I want so this is the name. So I want that to be, I want to save that as a track name. I'm going to use an alias, right? Which is when we say as, we're using an alias to represent that particular column from that table. So we're using the track name, which is the alias, to represent name. So as track name, and then we'll come back to that. Our first is the inner join. So we're looking for to join the album with artist. So let's go to album, view the data, artist, view the data. So with album, our primary key is album ID, and we do have a foreign key here as artist ID. In artist, we have the primary key as artist ID. So that means we're going to join album and artist based on the artist ID, which is a foreign key in albums and a primary key in artist ID. That is the key that links those 2 tables together and gives us the relationship between the artist and the albums. So here we would say our inner join would be on albums. On, and then I'm going to open the tracks table. So for the tracks, we could see that we have the track ID, which is the primary key for this table. Remember, the primary key is that unique identifier for each of the rows. So that's the track ID. But we also have the album ID, right, which is a foreign key. So that shows us the relationship between tracks and album, right? Because album ID is a primary key in albums, but it is the foreign key in tracks. So that's how we can link tracks to album and then link album to artist. So here we're going to do that inner join. We'd link albums to the tracks first, right? So we have that as track, album ID. All right, so that's how we've linked the foreign key in tracks to the primary key in the albums table. And then we have another inner join. So this time we're going to link artist to the album table, right? That's what we're going to link. So we'd have the artist, which we can, we can call it A2, or I will prefer to say AR, right? On. So our foreign key is in, for artist, is in the albums. Yes, artist ID, right? That's our foreign key there. So we would say albums, then artist ID equal to our primary key, which is artist ID. All right. Then we're just going to do an order by the artist name. All right. Okay, so our select statement, we can come back here and let's include the title. So album, then the title. We want to put that as the alias, which is album title, and then the artist name. We want that to save as artist name. All right. So the reason I did this last is because I mentioned the album table and the artist table at the very end of the query, right? So I wanted to do that last. So from our select statement, you can see our tracks table. That's where we get the name and we save that as track name. Then from our album, we get the title, we save that as album title. From our artist, we get the artist name and we save it as the artist name. Then you have the track. Our inner join, we start with the albums table, right? And we join the album ID, which is a foreign key in the tracks table, to the album ID, which is a primary key in the albums table. And we continue that inner join by joining, looking at the artist table, and the artist ID is a foreign key in the albums table, and we join it to the artist table, which the artist ID is the primary key in that table. And then finally, we order by the name. So if we run this, this is basically what we get. We get all the track names, their album title, and their artist name. So this is basically how to perform an inner join. So the next question we would look at is the left join, which asks us to list all artists and their albums, including artists who have not released any albums. So let's see how to perform the left join. So I would start with my select. I'm going to use a wildcard. I like using a wildcard because I haven't listed out my tables yet, right? But I know that the tables I'm interested in is going to be the artist table and the albums table, right? Those are the two tables I am going to be interested in. And I've showed that to you. I showed the data in those two tables to you previously, right? So from my first table is going to be artist, right? That's going to be my first table. So now I know what my first table is. I can come back and edit my select statement, right? Because I'm saying list all artists and their albums. So I would need the name, right? I think that's one of the very first things I will need. So in my artist, I need the name, right, of the artist. So I can come back here and change this to name and save it as an alias as artist name, right? We'll come back and do the other ones. Then the next thing is our join. So this is a left join. So left join, and we're going to join this on the albums. So I could use AL to signify albums, right? And remember, the artist ID is a foreign key in albums, right? And it is a primary key here. So that's what we'll be doing that join on. So we'd say on artist ID equal artist ID. If you try to join it on another key, it will return an error, right? You must join the foreign key to a primary key that are the same. So now that I know this, I can come back here and say AL, I want the title as album title, right? That's what I want it as. So then I could order by the name. Let me try something. We could order by artist name. Yeah. Okay. So this is basically how you would write your left join. So let's run the code. All right. So you can see our artist name, right? And it's being ordered from A to Z. And you can see our album title as well. So you could see that Egbe-Etu, right, artist name, but he doesn't have a name for his album title, right? Because our question says we should include artists who have not released any album. So this here means that Egbe-Etu has not released any albums, right? The same with Aerosmith and Sierra Leone's Refugee All Stars. They haven't released any album. All right, so that's it for a left join. The next thing we'd look at is a full join. And the question here says list all the artist name with their album titles. So select wildcard, which is our asterisk, from albums. Because we're looking at the album and the artist name. And we'll just do a full join. Artist on, so our albums, maybe I'll just come back here and say AR, right? So remember the primary key, is artist ID because that's what we're interested in, right? And then it's going to be a foreign key in the album. So we start with the albums first, artist ID, and we just equal that to AR artist ID, and you close that. So this is basically what you get. So it's a full join, right? We're just joining everything. So you can see our album ID, you can see the title, the artist ID. So to let you know that everything was joined properly, you can see that there's a match here, right? The artist ID from the album table basically matches the artist ID from the artist table. So you could see 1, 1, 2, 2, 2, and so on and so forth, which lets us know that a full join was basically performed. So artist accept, this is the name of their album title, which is Balls to Wall, right? Or Let There Be Rock, AC/DC. That's the artist name. All right, so that's how we perform a full join. Finally, let's look at the last one, which is a self join. Find employees with the same job title. So here, remember we want to perform a self join. We're joining the table back to itself, right? So we have our select. I would start with the asterisk here, and I would come back and edit that. But our table is going to be the employees, right? That's the table we're interested in. So I'm going to open that because I've never opened it before in this video. So let's view. So this, we have 8 employees, right? These are their first and last name. So our goal is to find employees with the same job title, right? It's a small table, and obviously when you look through it, you could easily spot the employees with the same job title. But if this was a very large table, it would be difficult for us to do that, right? So that's where SQL basically comes in. So now we need to name our different tables. So we can say first one would be employees E, and you can call another table and say employees E2, right? So you have your first table as E and your second table as E2. Now I would come back to my select statement and make some modifications to it. So the first one would be that I want their first name to be saved as first name 1. Now E2 is their first name. So now I'm looking at, so I've saved the first and last name for the first table as first name 1 and last name 1. Now, we duplicated that table. Now I'm going to save it as first name 2 and last name 2. Okay. And then finally, I want their title. All right. So that's that. Then we have a where clause. We could say E. So remember, we still have to join. We're joining this based on the employee ID. And then their title. Then I want to order by their title. Okay, so we can close this query. All right, so I have my select statement and all of the different aliases as well as the title. Then we have the joins, the same table. We just name it E and then E2. Then we have the where clause that helps us to join this table based on the employee IDs, and then also the title as well. And then we order by the title. So if I run this is what we get. So Robert and Laura have the same title as IT staff, right? So what you would notice here, it would look like a repetition, right? But it's not a repetition, because what it is doing is that in the second line, it's now going to join Laura and Robert. So before, it just looks at Robert alone, right? And then it goes through the database and see which other person has the same job title as Robert. So Laura does. Then it goes to the next person, which is Laura. Which other person has the same job title as Laura? And that's Robert. So it's basically going to do that. So you can see that for Jane, it starts with Jane, and it says that Margaret has the same job title as Jane. Then it goes back to Jane again, and it says that Steve has the same job title as Jane, right? So it's going to take it and run through the database, right, to see who has or who meets that requirement. If they meet that requirement, it writes it down, and it just keeps doing the same thing. So that's what a self-join is all about. Okay, thank you for watching this video, and See you in the next one.